है, इसमें जो पंच जो मेन वही पॉइंट है क्या, हाउ डू वी गेट टू दिस टेबल, राइट? तो quickly at time 0 500 gram block oscillating on a spring observed moving to the right at x equals 15 centimeter, right? तो अब देखें ना, ये अब इससे क्या आप गेस करेंगे कि एम्पलीट्यूड है? कैन वी गेस? Because there is nothing which says that, yeah, it's just a point, yeah. Of course t is equal to 0. अब अगर आपके ज़हन में आ रहा है कि t is equal to 0 पे हमेशा एम्पलीट्यूड होगा, तो आप किसी एग्जाम्पल को कॉपी कर रहे हैं ना. So all it's saying is that the value of position, yeah, at t is equal to 0 is 15 centimeter. That's it. There is no other information. So you cannot say anything else about it. So read on. It reaches a maximum. अब देखो ना, ये असल बात आ रही है. It reaches a maximum displacement. अब वो amplitude होगा, और वो क्या है? 25 centimeter. And that happens at another time point, which is 0.30. अब यहाँ पे naturally आपको labeling करनी पड़ेगी. So if we label that point as 0, and if we label this point at 1, so we have x0 equals 15 centimeter, right? x0 equals 15 centimeter, and x1 equals 25 centimeter. Is not just 25 centimeter, I'm also calling it A. Yeah, so I want to make sure that everything is in place. Yeah, and t1 equals 0.30 seconds. But there is something else which I can write. Yeah, so what does it say? It's not just the value, it's a observed moving to the right. That is something which I need to capture, and that is at least I can say that the velocity initially, yeah, vx0. Remember, I don't write v because v is the speed. So vx0 greater than 0. And remember, when we have 0, we don't need to write units. Yeah. So even if you write 0 meter per second, 0 meter per second is the same as 0, yeah? Because 0 can turn anything into 0, even a unit. So that's why we can make our life easy, but not by not writing units when we are dealing with zeros. Okay, that's it. Next, what is the question? These are the question now. Draw a position versus time graph, right? And whenever you have this thing versus this, so the first one has to be on the vertical axis and the second one has to be on the, because this versus this. So that is the independent variable and this is the dependent variable. You know, this computer science community, they have started using very interesting names for this. Like instead of calling it the vertical and the horizontal, yeah. I mean, what if you are in an airplane? There's nothing vertical. Yeah. So this is, they call it the value axis, and I actually like that terminology. Math guys still use this x-axis and y-axis things, or abscissa and ordinate. Even that is not easy to remember. Yeah. So what these software developers, they have in documentation, they use the value axis, yeah, and this is the argument axis, because it's a function, yeah. So anything you give n to the function as an input, it's called the argument, and the thing you get out of that is the value. So value axis and argument axis. I simply love that name. See? So I would also use that in my notes. So this is the first thing we need to do. So how do I capture this task and the find thing? So I am looking for the graph, yeah, graph of, yeah, this versus this, and you know, I'm now using the function notation which you use in calculus as well. T maps to x, and because in a graph I cannot have units, so sorry. Okay, because I cannot have units, so I have to get rid of units. So times per second and position per centimeter. In this case, centimeter is the easiest unit to deal with. I don't need to convert everything to meters, right? So this is the thing which I am going to work out. Graph of the function from t per second to x per second. And this is something which you need to remember, because when you are graphing a function. So it will be wrong to say graph of x, because x is not a function, right? So graph of t maps to s, which here you say position versus time. And the next thing, part B, what is the maximum force, right, on the block. So that will be F max. You can either call it F max or you can call it F x max. Yeah. Better would be to call it F x max. And not only that, what is the first time at which this occurs? So you need to find the time as well at which that happens. And why is he saying first time? Why does it need to be mentioned explicitly? Why not simply, what is the time at which this occurs? Because we know this is simple harmonic motion and it's a periodic motion. So this will repeat, right? So you need to know which one. The first time, the second time, the third time. I can change this question, I can change this to the second time, then it will have a different answer. So now you should appreciate why we want this phi to have values above 2 pi as well. Yeah, one rotation 2 pi, second rotation 4 pi, 6 pi. So otherwise you have no way to track that. बात समझ आ रही? So after that, so now this automatically leads to the new label 2. So I'll label that point as label 2. So which means that I'm looking for, yeah, you can say fx2 and t2, and that fx2 is also fx max. So the rest is very easy. You just work out the phase constant. This is something we always do, right? And then you go to the, so you plug these values, and then phi naught, right, is cosine inverse, cosine inverse, cosine inverse, and then when we get to calculator, we get r cosine 3/5. That will be a value, and that can be either plus or minus. We cannot say that. And in theory, we can also have 2 pi, 1 plus minus 2 pi, yeah, plus minus 4 pi, plus minus 6 pi. So we want to have all those possibilities open. So how do you figure which one to pick? By which one I mean whether I pick plus or minus, that's one thing, and whether I add 2 pi one time or 2 times or 3 times, right? So now for that, this information is needed. The position is positive and the velocity is positive initially. Now this was written down, yeah, move to the right. How do I, where does this come from? Because the value I got is initially plus 15 centimeter, right? What does it say? At x equals 15 centimeter. Now because we know x has a sign, x can be positive or negative, so this 15 centimeter is plus 15 centimeter, right? So we can conclude both the position and the velocity at time 0 is positive. So which quadrant is this? The fourth one. The fourth one, not the first one. All the first one is also possible, but in this case it's the fourth one, which means that we can pick this to be 0, no extra rotation needed, and we pick that one to be negative, yeah, because the fourth one will have a negative value. So negative r cosine. Calculator only gives you this value. This negative is something you have to write down using your own head, yeah. You cannot leave everything to calculators. So then we have minus 0.93 radians. So we have not yet solved anything, yeah. We just converted this piece of information to the value of phi naught. But let's get to the actual question. Actual question मुझे क्या चाहिए? I need to draw a position versus time graph. So, but for that, this phi naught was needed, right? But is that the only thing I need? Remember, you must always have this thing in mind. If I want to plot something, I need to have an equation, and that equation must be for the position. So what is the template? The template is, we always use cosine, yeah, the shadow on the x-axis. And here you need an amplitude. Amplitude, we know it, that's not an issue. 25 centimeters. So now we also worked out the value of phi naught. That is also there. And we know there is a t in it. No, this t, don't try to find the value of t, because t is just the coordinate, yeah? It's the free variable t and x. Yeah, so this t and this x, we will leave them as they are, because there will be the labels on the on the graph, and we will have the value of A from the table, the value of phi naught from the table, and then we need something here, and that thing is omega, right? Either omega or 2 pi by time period. So let's write omega. So now how do you figure out omega, right? So how do you figure out omega? For that, we need to use this information. It reaches a maximum displacement of 25 centimeters. So it means that we will still use this equation, but we will replace t and x with actual values, which is t1 and x1, because we know those values. T1 is the 0.300 seconds, and x1 is actually a. If you think about it, it is actually a, the highest value. And then I'll use this graph now. So a equals a cosine, right, omega plus phi naught. And I could even make my life easier by just calling it phi 1, because I can call this phi. Phi is just the phase. So phi is the free variable, and phi 1 is the specific value at point 1. Yeah. So x1 equals a times cosine phi 1, and I'll get to this later, right? So अब इसमें क्या क्या unknown है? A तो पता है मुझे, वो cancel हो जाएगा. So 1 equals 1 times cosine of phi 1, which means phi 1 has to be something which gives me the maximum value, cosine. So cosine of what is 1? Cosine of 0, cosine of 2 pi, cosine of minus 2 pi, yeah, all those possibilities. So let's write all those possibilities. So now I'm writing x1, which is equal to a, which is equal to a times cosine phi 1, and that means phi 1 equals, and make sure you use proper symbols, okay? This is equal acceptable, this is equal acceptable, but you cannot have an equal sign there, yeah, because I'm using this equation to conclude that phi 1 is that thing. Now I cannot have an equal sign there, and you cannot tell me, oh, I meant this or meant that. I don't care what you meant, I only care about what you write, yeah, and whatever you write has to be correct. That's the rule for this course. So you know how to pronounce this, yeah, implies, yeah. So this equation implies, or from which we can conclude, that phi 1 equals, I mean, if you don't want to be bothered about this, you can just write it on the next line, yeah, and you can say therefore or whatever, but never place an equal sign where it doesn't make sense, yeah? Because equal means this side and this side are equal. This phi 1 is not equal to this, yeah. So no matter what you mean, this will always be incorrect. So phi 1 equals, of course, phi omega t1 plus phi naught, and that has to be, because 0 is one possible values, so 0 is the thing I get from the calculator, right? The arc cosine is 0, and then plus minus 0 is still 0, so I need to figure out whether it 2 pi times 1, 2 pi times 2, and so on and so forth. So how do I figure this out? Now this is tricky, this is the difficult part. That's why I included this in the notes. So if you have a tentative graph, because answering this part is not easy, so I need to sketch something. And this is also something you need to learn, because even if you have not everything, if you don't know all the pieces of the puzzle, you can still start somewhere. So what can we do so far, right? So that graph we are looking for will have, of course, the time axis, right? And of course it will be per second, and this will be per centimeter. So how does it start? Can I start from here? Can I start from the maximum value? Neither it's the maximum value nor 0. We know it's 15, right? So it was somewhere, the value was 15. And what's the maximum value? If this is 15, then this has to be 25. That 25 is actually the the maximum value. So it means that the graph has to start something like this. Yeah. So that is the maximum value. And that point is, this was 0, right? And this is, you mentioned, you know it. It is 0.3. 0.3. So do you see this is something which we can do right now. Yeah, it started. And why did I not go this way? Because it says moving to the right. So moving to the right means velocity is positive. And when velocity is positive, x can only increase, it cannot decrease. If it was moving to the left, I would have started this way. So not only do you know where it starts, you also know how it will move. Yeah, so it can only go up, and it cannot go beyond the maximum possible value. So after that maximum is reached, then it has to come back. Yeah, it has to come back to the equilibrium. That's what oscillation is. So now what can we say here? We need to figure this thing out. Yeah, phi naught is clear, but what is phi 1? Phi 1 is remember, for every time there is a phi. Remember, why? Because phi equals omega times t plus phi naught. When I change t, omega and phi naught are fixed. So when I change t, phi will also change. So for every value of t, there must be a value of phi. So we need to figure that phi 1. So what is t1? This is our t1. So what is phi 1? How do we figure that out? Now we need to find ranges, because this can be anything. Yeah, this can be 0, this can be 2 pi, this can be 4 pi. We need to find. So how does this graph now help me? One thing is clear. And what was the value of phi here? Can you tell me? What was phi naught? Because we know the value here. Yeah? So phi naught was, we figured it out, right? Minus. Pay attention to this. And in your coordinates, it will look like this. Yeah? A tiny angle in the fourth quadrant. So this is minus 0.93. This will be 0, right? What will be this? This will be plus 0.93. So this is, remember, this is your 0.0. I'm just putting it in a square box. So this will be what? If this is phi naught, this has to be minus phi naught. No, not phi 1. We don't know anything. I'm just flipping it out. So if this is minus 0.93, this will be plus 0.93. So it means that if here I have phi naught, here just by using the same value, because in dono mein x same hai na. So I'm like, I reached the maximum value, I'm coming back. Now I'm back at that point where I had time 0 and phi naught 0. So when I come back to that point, I don't know anything else, but one thing what I do know is that the angle will be, the phase will be minus phi naught. So this point will correspond to phi naught with a negative sign, which is, I'm just writing it for you, which is plus 0.93. I don't need to write radians, you know that, yeah? So what can I say about, and remember, I am looking for phi 1. So I know that phi 1 has to be between these two values, right? Because I know phi changes, yeah? Phi starts from 0, and with every rotation, it keeps increasing. It never comes back, yeah? So plus pi by 2, plus pi, plus 3 pi by 2, plus 2 pi, then 4 pi, 6 pi. So phi can only increase, remember, because t can only increase. When t can only increase, phi can only increase. So what can I say about phi 1? Phi 1 has to be higher than phi naught, because it's a new time, but it has to be less than minus phi naught. So it means that it has to be, can it, Now look for the possible values. What are the possible values? 0, 2 pi. So can it be 2 pi now? No, it cannot be 2 pi because it has to be less than 0.93. So it cannot be 2 pi. So the only acceptable value is 0. But you have to reason about it. You cannot say 0 because the calculator gave me 0. No, that's not a reason. This is 0 because the calculator gave you 0, and it has to be between minus 0.93 and plus 0.93. So everything you know about the question matters, right? So now we can safely say, and I have written this down for you so that you can understand it. Since point 1, read this carefully, was reached from point 0 by moving to the right, yeah? For the first time, this actually happened for the first time. We picked the value that satisfies phi naught is less than phi 1 less than minus phi naught. So that is phi 1 can only be 0. It cannot be 2 pi. I just change a few words and I can make this 0 to be 2 pi. But you have to be watchful. Now, so you cannot simply copy this example. So all I have to do is just change one word and then this will become 2 pi. I can even make it 4 pi, yeah, depending on how I play with the words. So you now solve this, and from this because that equation has omega as the unknown, you can solve it, yeah. So omega is minus phi naught by t1, and now that is 3.1 radians per second. So now I can get back to this equation. So what do I know? X1. Now I get back to this one. X equals A, right? Cosine, and A I can even write the value. That is 25.0 centimeters. And omega now, 3.1 radians per second. Write the units times t. Don't try to write the value of t because t will be in our graph. Yeah, this was t1, but that we needed that only to figure omega, and that's now we're done with t1, t0, t1. So now you get back to t. T is the free variable. Plus, what is phi naught? Minus 0.93 radians, right? But this is not very clean. We are supposed to plot x per centimeter, so let's bring that centimeter here so that this is a clean 25.0, right? And there is already t per second, right? So just remove this t per second and make this t per second, and now you can get rid of radian because it doesn't matter whether you write it or not. Radian is optional anyway. Yeah? Degrees is not optional. So now I can plot this. Yeah, x per second equals 25.0 cosine 3.1 times t per second minus 0.93. And that is the graph. You can now see it. You can confirm it. Yeah, that it started from 15, it reached 25, and so on. Now the graph will now help you answer the second part. The second part is more challenging, right? And what does the second part say? यहाँ तक कोई क्वेश्चन है किसी को? Okay. Yes. No, the angle is negative. Fourth quadrant angle negative. Phi is the angle, right? So what is the second part? So is everyone clear that we are in fourth quadrant, phi naught will be negative, yeah? Negative 0.93. Although the calculator will give you 0.93 plus 0.93, but you cannot go with the calculator, right? Because all the calculator knows is that the answer has to be between 0 and pi. Yeah, the cosine, the arc cosine gives a value between 0 and pi, and the arc sine gives you a value between minus pi by 2 and plus pi by 2. You can always look it up on Google. So now the second thing, what is the maximum force? Fx max on the block, and what is the first time at which this occurs? So how do we figure this out? Can you use the graph for that? I'm now displaying the graph. Now for that we need to write the equations, work it bit by bit, yeah? So force fx, right? Fx depends on what? Can I say f equals ma and ma will help me? I will do that, but not at this point, because f equals ma is when I know force and I want to know acceleration. That is the utility of second law. That doesn't tell you the source of f. Yeah? So never use f equals ma for figuring out where the force comes from. For that, you need to find the source. And what is the source of force in spring mass system? The spring. Spring is giving you the force. So you need to use the Hooke's law. F equals negative kx. Now, that negative kx can still be used in f equals ma, but that is not what we are doing here. Yeah? So you need to know what you are doing. Just because you know a formula doesn't mean that you use that formula everywhere. Yeah? So every formula has to go through your head, and only then you can write it down. So what we do here, fx equals minus k x. You know that. And I don't care whether I know the value of k or not. Right? At this point. Why? Because all I need to know is the maximum force. So the maximum force doesn't require me to know the value of k. Right? Okay, by the way, this is also equals to ma. So I'm writing that as well. max. Why do I need to write that down? Not because f comes from there, but because I know the value of m in this question. I don't know the value of k in this question. Because I know the value of m in this question, I'll use this for computation, but I'll use this for reasoning. Right? And that is also, remember, I cannot have a minus sign there, because f always equals ma. Right? There is no minus sign in that equation. The minus sign comes from the Hooke's law. So you'll only put it when you're writing down the, तो जोश खिताबत में ये माइनस साइन उधर नहीं लिखना कि f is equal to minus ma. Yeah, f is equal to minus x, kx, and that is then equal to ma. So because Newton's law doesn't give you any minus sign, right? So now, so what does this mean? That the maximum value of this force will be tell me. I told you for reasoning I'll use this. So the maximum value of force will be when the value of x is minimum, because there is a minus sign. आपने x को भी maximum कर दिया तो minus x maximum तो दूसरे end पे चला जाएगा ना. So minimum. So f max x equals minus k x min, because the minus also has to be taken care of. So what is the minimum value of x min? What is x min? Tell me. X max is a. You know that, yeah? So what is x min? Minus a. Right? X min is minus a. So what do I do? It is, right, minus k and minus a. So it means k times a. But because I don't know the value of k, so I have to get to ax. So, but what I also know is that ax equals minus omega squared x. That's what we learned last time. Ax equals minus omega squared x. So I can replace this x min, right? X min omega squared will give me ax what? Max or min? Max, because there is also minus sign. Yeah? Yeah. So the minimum here multiplied by minus will give me the maximum value. So ax max, and it makes sense as well, because m is positive, fx max will mean that ax also has to be max. So what can I do here? I can now, instead of writing k, I can now use this thing, yeah? So fx equals m. Now I can use this equation, yeah. So fx max equals m times, right, ax max, m times ax max. And what is that? M times, right, omega squared x men with a minus sign. Yeah. So minus m omega squared x min. And what is x min? Minus a. X min is, that minus will cancel out this minus. So I'm left with m omega squared a. And why did I go through such a complicated path? Because I know the value of m. I just calculated the value of omega. And I also know the value of a. So no matter how unpleasant this path is, that's the only path for me, because I have no way. अब अगर k मुझे पता होता तो मुझे ड्रामे में पढ़ने की जरूरत नहीं थी. I would just have used that value. So sometimes you are just unlucky and you have to go through a complicated path. Yeah. So but you know what we are doing. Yeah. We know omega x. So now I'm just showing you that value, right? So now pay attention to this equation carefully. F max, you can write x here as well, is m a x max, and that is minus omega squared x min, and that is plus m omega squared a. And now I have to plug all the values. So I have 1.2 newtons, right?
लास्ट लेक्चर में एक फार्मूला बताया था मैथ्स में, ओमेगा इज इक्वल टू के बाय m का स्क्वायर रूट. यहां से के रखें निकाल सकते हैं.
Omega equals to
k by m का स्क्वायर.
yeah, but we don't need k here.
हां, तो k वहां से निकालेंगे तो ओमेगा स्क्वायर by m.
Yeah, I know. That's another way of doing it. Yeah. That's one. Yeah. But because we need force, so we can simply use that equation. If if you are asked to calculate the value of k, then we can do those things. Yeah? But now the question is about maximum force. So force is related only to these two things, minus kx. I can even replace this thing. Okay, I can completely, yeah. But I just wanted to remind you that minus kx should also be in your mind. But actually, if you want to explain the force, that is the only thing. Yeah? So right. So now we know what we know, fx max. But that's not the only thing we are asked. We also asked, because this is fx1, yeah, sorry, fx2 at point 2. This is the force at point 2, labeled 2. So we also want to calculate T2. Yeah? So what is T2? Tell me. One way is to actually use the same equation again. Yeah. So x2 is a times cosine omega T2 plus phi naught, and just solve this in the same way we solved for phi naught. जिस तरह phi naught के लिए हमने equation solve किया था. Now the beauty of this equation is that you can replace it with x0 t0, x1 t1, x2 t2. You can use the same equation. You just have to change the labels. So that is one way, and you can do that, right? But there is another way. I can save my time rather than going through all this complication. I can appeal to the graph. So can you tell me where that T2 is? We just learned that at that point 2, x has a minimum value and force has a maximum value. We know that, right? So the graph is also telling you where x has the minimum value, minimum value. Where does x have the minimum value? Yeah, this is the maximum value. This is the minimum value, and this is the zero value. So can you use the graph to calculate this point? Remember, you already know T1, which is 0.30. So what is the difference between 0.3 and this value? Half the period. ये अगर यहाँ पे आ जाए तो full हो जाएगा. यहाँ से T1, this will be, the next peak will be T1 plus 2 power, T1 plus capital T plus capital T, and this will be T1 plus half T. So I just need to know T1 plus half T. And what is T? I know omega. So T is 2 pi by omega. T is 2.0 second. So all you have to do is to add half of that value. So you see, just by looking at the graph, you avoided all that nasty calculation. Otherwise, you would have to use arc, cosine, and then, yeah, which quadrant. बात समझ आ रही है? So लेसन इससे ये है कि you have to use everything that is in front of you to save your time. And even better will be to go through that again, use that formula as well, and then confirm that you get the same value. Because if you don't get the same value, then something is going wrong. You must get the same value, whether you use it in this way or by using the equation. There is no way you can get two values. बात समझ आ गई? So let's get back to the slides. And what you must notice in these examples is that no matter how complicated the question is, you can always actually tame it by asking the right question at every stage. Yeah? Don't just take things for granted. Don't try to recall any other example. Don't try to memorize. Just follow the basic rules, and every time make sure that every step makes sense. And then it has to be. There's only one way to get to the answer. Yeah. If you follow that path. Sometimes there are two ways, and that is better because then you can confirm your, that in the SMART strategy, that R was for reflection. Yeah, so this is also a reflection that you compare the two answers. Yeah, if they match, then you have more confidence. So till this point, we have used just one physical example of simple harmonic motion. Remember, when I introduced simple harmonic motion for the first time, I introduced it as a type of motion without talking about how to achieve that. So remember, mass spring is one way of achieving it in nature. But you can define simple harmonic motion without using the language of mass and spring. You just say the motion is simple harmonic when it is sinusoidal. If the position is sinusoidal, whether it's cosine, whether it's sine, or whether it's any combination of the two, that's why you have to use phi naught. So remember, the value of phi naught makes sure that you can either have cosine or sine or any. Here it started from it was neither sine nor cosine. It was just a mixture of the two. And later on, we learned that can be achieved by using a spring and a mass. Spring makes sure that you get a restoring force, so it can store potential energy, and the mass makes sure that it responds to that restoring force. Just having restoring force doesn't matter. Just like we have, these electric power companies. Which power company is providing power to Islamabad? ISCO, yeah? Yeah, the old people, they still call it WAPDA, and WAPDA has nothing to do with power. Yeah, that was 30 years ago. So WAPDA all in a billion. WAPDA has nothing to do with power. It is only dealing with water, right? Interbella. So it's ISCO. So ISCO is providing you that socket, yeah? And that socket has two outlets, and it gives you voltage, yeah, what you call voltage. That is potential energy. That is not useful unless you actually close the circuit. Yeah. So just having the restoring force is not enough unless there is a mass to respond to it. And when the mass responds to it, it converts that potential energy to kinetic energy, and it can store. Just responding is not enough. It must be able to store it as well. So mass is good because it responds to that restoring force by F equals ma, number one. Number two, half mv squared means that it can also store it. I can give you examples where something will respond, but it will not be able to store it, right? So that's also not good enough. So now we have spring and mass, and you have this exchange of energy between two forms, and there is nothing else going on, so you have simple harmonic motion. Now we need a second example. Yeah? And in that second example, we will together, and I'll keep asking questions, figure out what is it in that system that is storing kinetic energy, and what is in that system that is storing potential energy. And unless we figure those two out, there is no way we can explain simple harmonic motion. So that example is actually I leave some of these MCQs to you because they're very simple. Yeah, ये आप खुद कर ले. Just because I leave certain MCQs doesn't mean that you will not be trying. मैं चूंकि इन क्वेश्चंस पे ज़्यादा टाइम लगा रहा हूँ तो ये आप खुद कर लेंगे फिर, ठीक है. So let's get to, so I'm leaving these MCQs. Yeah, they're very easy. So simple pendulum is the next example, right? So we need to everyone knows what a pendulum is, right? But we need to understand simple. Why do we call it simple? Just like simple harmonic motion, we call it simple pendulum because this will give us simple harmonic motion. That's the reason. Yeah? So it's not a complicated pendulum. Now, why do we say it's simple? Yeah. So you have seen these diagrams, yeah, many times. What you need to know is that this rod has to be massless. It cannot have any mass. It cannot have any other property either. It cannot have spring constant. It cannot have mass. It cannot have charge. So you see, this is that modeling approach. Everyone knows that every rod you pick, for example, if I want to use this in a pendulum, this will have mass. So how do I deal with this? We know this will have mass. So how can I say this is massless? What is the way out? मसला समझ आ रहा है कि जो भी मैं रॉड यूज करूंगा उसका मास होगा, तो मैं कैसे कह रहा हूं कि ये मास लेस है? So I will make sure that because there is another mass here as well, so when I'm producing this thing physically, I'll make sure that this mass is much larger than that mass so that it can be ignored. तो अगर आपने इन दोनों का मास सेम रख लिया तो फिर ये सिंपल पेंडुलम नहीं हो सकता, ठीक है. सिंपल पेंडुलम तब होगा जब इसकी डेंसिटी बहुत ज्यादा होगी, नॉट जस्ट मास बट डेंसिटी, इट हैज टू बी स्मॉल एज वेल. या ऑल द मास. सो इसका अगर कोई मास है भी, आप अपने मॉडल में उस मास को कहां पे रिप्रेजेंट करेंगे? यहाँ पे. यू विल इमेजिन एज इफ ऑल दैट मास इज there. So now what are the assumptions for a simple pendulum? A rod with zero thickness. So even अगर कोई diameter है भी आप ignore कर दें. It is so small compared to other quantities that it can be ignored. And it has zero mass. But it still needs to have one property. समझ आ गई? जिस तरह आपको याद है मैंने जब एक थर्ड लॉ ऑफ न्यूटन एक्सप्लेन किया था, we in most of the problems we are modeling the ball we throw against a wall. We model that as a rigid body, and we model the wall also as a rigid body for calculations. But when we want to explain why does the wall actually repel the ball, yeah, and why do we have a bounce back, we need to actually zoom in. And we have to model the ball as a spring, and we have to model the same wall as a spring. Parts which are interacting, they must behave like springs, and only then we can explain. ये बात समझ आ रही है? So this rod, even though it's massless, even though it has no diameter in our model, but this still must have one property, and that property is that it must be able to support this thing. Otherwise, it will just break. So we need to attach properties, massless, diameterless, but at the same time, this will be strong enough. So it means that it must be able to carry the tension force. Remember tension. It must have tension in it. क्योंकि अगर मैं टेंशन भी इससे निकाल दूं, मैं कह दूं कि इसमें टेंशन भी नहीं आ सकता, तो फिर तो ये पेंडुलम आप बना ही नहीं सकते. But don't worry, these things are actually manageable. Later on in a complicated model, you can bring all things back. Yeah. So it will now have only one property, length, and another property that it can carry the tension force. And now this mass will respond to the gravitational force from the earth, right? So if I now, one more thing is this, you need to understand these two quantities. This is the angle theta. And because in a simple pendulum, you don't want this pendulum to rotate like in a circle 2 times or 3 times, right? So remember, so far that phase phi was allowed to have values larger than 2 pi, right? Because it was the spring mass was oscillating, and in the circular view we had 2 pi, 4 pi. This theta cannot be more than, it cannot be even 2 pi, because what would that mean? What does it mean for this theta to be 2 pi? It means that you want the pendulum to behave like that. That is not going to happen. So this theta can only be, yeah, if you think of this as a quadrant, it can only be in that quadrant, or it can be in this quadrant. Yeah. So positive in the diagram, and this will be negative. The maximum value will be pi, and the minimum value will be minus pi. And even that is stupid. Yeah. I mean, just imagine pi. I mean, we'll get to that later. What is this S?
Displacement. Arc length.
This is arc length, and as written, but there is one problem with this name. When you call it arc length, length by definition cannot be negative. You know that. No length can be negative. So a correct name for this is actually, there are many ways to talk about it. One is signed length. So it is actually a signed length which has a sign. Some people call it oriented length, and some people call it directed length. There are many names. Yeah. So you need to use something to indicate that it can have positive as well as negative values. Just like area, sometimes we typically talk about area as being only positive. Yeah, but if you use the normal, yeah, normal to a surface, the normal to surface. So you can have the area will be positive if the normal to it is actually outside, and if the normal is inside, the area is negative. We even have signed areas, yeah, oriented areas. In calculus, you will be learning the integrals, right? Which is the area under the curve. So although you use the word area, it's actually a signed area, because if you simply call it area, area cannot be negative, and integrals can be negative. Yeah, a to b and b to a minus. So that is signed area, and this is signed arc length. So it means that this s will be positive and this s will be negative, right? And what is the relationship between these two? Can you tell me how are these two things related? S equals L times theta, because this is a sector, right? So because this is a circular arc, so S equals L times theta. That must be in the back of your mind. The only difference from the math is that in math these two cannot have any units, but in physics all these, at least these two will have units. This cannot have units, but L will have the units of length, centimeter, meter, or something, and this will also be meters or centimeters. So let's get to the free body diagram. अब मुझे ये बताएं यहाँ पे, can you now tell me, without getting into the mathematical details, can you tell me which of these two things will give me a mechanism to store kinetic energy? So I need a mechanism to store kinetic energy, and I need a mechanism to respond to forces. तो कौन सी चीज यहाँ पे वो रोल प्ले कर रही है? स्प्रिंग मास में वो क्या था? ब्लॉक था ना, ब्लॉक. The spring was producing the force, but the block was responding to the force, and it was storing kinetic energy. So which thing here is responding to force and storing kinetic energy? Mass, yeah, because this is massless. So the rod cannot do it. This block can do it. Or particle, you can model it as a particle. Now, what is it that will store potential energy? बताएं. We also need one mechanism to store potential energy. Otherwise, we cannot have simple harmonic motion.
The string.
No, the string I told you. The string. नहीं, string massless है, और mass ने तो वैसे भी वो store नहीं करना था. So if you expect the string to store potential energy, then it must be elastic. It must have a spring constant. तो spring तो नहीं है ये. So ball cannot store potential energy. I told you, it can only store kinetic energy. The earth, it is interacting with the earth. So the space between this mass and the earth, the surface of the earth, that space will be storing the gravitational potential energy. I told you many times, gravitational potential energy is stored in the space between two bodies. Elastic potential energy is stored in the spring, but this is not a spring, right? And we know mass cannot store. And forget about all those statements in textbooks that the potential energy of the mass. Yeah, they don't bring this issue because in schools it's too much to handle. तो वो आसानी के लिए बहुत सारी, जिस तरह बच्चों से बहुत सारी चीज़ें बोलते हैं ना, वो कहते हैं वो जो है ना वो आप कहाँ से, वो बच्चे कहाँ से आए, कहते हम उधर से ले आए थे, बस कोई एक परिंदा छोड़ के गया था. So it doesn't mean it's true. Yeah? You say many things to kids. So you were told many things which were wrong, right? And this is the real deal now. Only space can store potential energy. So don't argue about the school things with me. Okay. Now we need a force, we need a free body diagram. So because that is the only thing that is going to respond to forces, so free body diagram will be for that thing, right? So this is the gravitational force, right? And this gravitational force, because we need to talk about this length as well, yeah, this rod. So it will have a component opposite to that tension force. Remember, it has the tension force. So if you decompose this gravitational force, one will be in such a way that it will be balancing, or it will be balanced by the tension force. So as far as these two forces are concerned, they are balanced. So this block or this particle cannot move in these two directions, right? Because it can only move in these two directions if these two forces are not balanced. So what about this force? This force is the component of this gravitational force perpendicular to the rod. Remember, ये मेरे पास rod है और यहाँ पे मेरे पास ये gravitational force है. इस gravitational force का, I'm not interested in the x and y. I'm interested in the component of this force along this line that will be balanced by the tension force. So this will be F, I will say F, how can I call it? Normal. Yeah, it will be normal, yeah, normal force. And this is the tangential path, yeah. Why am I calling it tangent? Because this is why the particle will move. अब पता है chapter 4 में, if something is moving in a circle, so the tangent to the circle and then normal, right? तो ये चूंकि हमारा center ये है आपका, this is the center, so वो radial, you can call it radial component or the normal component. और ये क्या होगा? ये it will be normal to this, but it is all tangential. तो यहाँ पे typically लोग क्या लिखते हैं? T for tangential. But there is a problem with that. Many people don't have any problem with T. So N, you can use N for normal, and we use small n for normal force, so that doesn't cause any confusion. Can you tell me which confusion is caused by this T? Because we use it for time. Normally it doesn't matter, but it matters here. You know, we can use the symbol T for the capital T, we can use that for tension, but that capital T we also use it for time period. As long as this slide does not have both, we don't have a problem. We can use that same T for tension, right? बात समझ आ गई? इस स्लाइड में चूंकि टाइम पीरियड आ ही नहीं रहा, सो वी डोंट गेट कंफ्यूज्ड. बट इसी स्लाइड में अब मैं आपको बताऊंगा, ये भूल गया है कि इसी स्लाइड में वो टी को टाइम के लिए भी यूज कर रहा है. दैट इज नॉट एक्सेप्टेबल. कैसे? इस टी का क्या मतलब है? टेंजेंशियल कंपोनेंट. इस टी का क्या मतलब है? You cannot have the same symbol with two meanings in the same slide, just next to each other. That is not acceptable. So it's too much. So आपको क्या करना पड़ेगा? You need to use another symbol, and we already have a symbol. मैंने आपको क्या कहा था S के बारे में? S is a signed length. So we can simply replace this T with S. We know S is positive there and S is negative there. So we have a free variable. We can use that. We can even use theta. Remember, theta and S, they both vary in the same way. Theta positive. So you can either label as theta. आपको याद है जब मैं चैप्टर 4 एक्सप्लेन कर रहा था तो मैंने T का भी यूज नहीं किया था. मैं क्या यूज कर रहा था? I was using S, and this was for the radial and this was for tangential. Okay. So you can you now you have to replace this with S, and then okay. So where does this equation come from? And how do we compute? We don't need to compute that. Why? The radial component. Because we know it's balanced by that and we don't need that for us. There is no motion in that line, right? So how to compute this thing? You need a triangle, right? This is the triangle. ये क्या हो गया? Theta. और ये force, and you can even have this one, right? You can even have this one. तो अब बताएं ये एंगल कौन सा होगा? अगर वो थीटा है तो ये क्या होगा? Can you figure that out? Okay, maybe it's easy for you to figure this angle out. Okay, how about this one? I know that theta. So let me try something, yeah? This is a tip which will help you in many problems, right? Question समझ आ रहा है कि मुझे ये एंगल मुझे दिया गया है and I first tried this one, then I tried this one, and now I'm trying this one, and I will have to settle with that one. I'll tell you why. Let's say you have, so I'll now explain one thing. Let's say there are two lines, right? And they are moving in certain directions, and you know the angle between them, right? So let's say some particle is moving along this direction and another particle is moving along this direction. Let's say this turns 90 degrees to the right. Yeah, you can also imagine to the left, but let's move to the right. And let's say this particle also moves 90 degrees to the right. दोनों ने अपना path change किया by exactly the same amount. What will now be the angle between them? The same angle, because both has been changed in the same way. ये बता गया ना? So दो चीजों के दरमियान अगर कोई angle है, so if they both change in the same way, if they both rotate in the same way, the angle will not change. अब आप देखिए इसको जरा देखिए, यहाँ से मैं वो start कर रहा हूँ, तो imagine a particle moving along this line and another particle moving along this line. The angle between is theta. Look here. Here, imagine this line turning to the right, right? And imagine this line turning to the right. So the angle will still be the same. So actually this angle will be, this angle will be theta. And you can actually use these, some of your knowledge from trigonometry. It will actually turn out that this angle is also, this angle is theta and this angle is theta. So आप ये बताएं कि अगर ये आपका force of gravity है, तो ये क्या होगा? ये कौन सा component होगा? नहीं, I think theta ये होगा बिल्कुल. Theta ये होगा. ठीक है? So this will be, this will come with sine and this will come with cosine. ठीक है? So you have sine. Now, sine का तो मसला हमने हल कर दिया ना वो उस तरह से, turning right or turning left. Where does the minus sign come from? क्योंकि इस t को जो आप s से रिप्लेस करने वाले हैं वो किस साइड पे है? राइट साइड पे है, और ये फोर्स किस साइड पे है? So that coordinate label is the reason why we have a minus sign. Remember, I told you minus sign will only be determined by the coordinates you are using. Yeah. So अगर आपने इसको t कहा होता तो फिर ये प्लस होता. समझ आए? हमने उसको t क्यों कहा है? क्योंकि we want this angle to be positive. अगर आप ये पॉजिटिव करना चाहते हैं फिर वो थीटा नेगेटिव हो जाएगा. ठीक है, फिर आपको ये पूरा डायग्राम इस साइड पे करना पड़ेगा. So is this clear now? Minus mg sin theta. Minus is because of the coordinates, sin theta is because of this angle and this angle are actually the same. मेरे ख्याल में ना इसको आप उससे भी कर सकते हैं, वो शायद ज्यादा कॉम्प्लिकेटेड लग रहा है. ये दो लाइन्स पैरेलल है ना, और ये सेम लाइन है, सो मे बी इसको हम क्या कहते हैं, करस्पॉन्डिंग एंगल. करस्पॉन्डिंग एंगल, राइट, दीज आर करस्पॉन्डिंग एंगल. सो इवन उसकी भी जरूरत नहीं है, वो जो मैं वो 90 डिग्री कर रहा था. So what can cancel out in these two equations? अच्छा, ये मैंने क्यों लिखा है राइट साइड वाला? You have to tell me that before I write that m times a thing, ये सारे क्या बता रहे हैं मुझे? ये सारे they are telling me where the force is coming from. ये बहुत जरूरी है. जिस तरह वहां पे मैंने क्या कहा था कि एक आपका वो f equals minus kx वाला था equation, that was telling me where the force is coming from. And I will write ma when I know how the mass will respond to that force. So this thing you are always going to write at the end, because this is something which will always be true. But here I am writing down what force is being applied to the mass in this direction, right? Because this is the only direction in which it will swing. The pendulum का जो swing है वो इस direction में होता है, इस direction में नहीं होता. So m cancels out and you are left with minus g sin theta, और a tangential क्या होता है? Acceleration. Remember, first derivative of velocity, and velocity is also first derivative of displacement. तो ये क्या हो जाएगा? Displacement. But instead of x we have s. x हम यहाँ पे क्यों यूज नहीं कर सकते? Why can't we use x? Like we typically use x in a straight line, right? This is not a straight line, this is a curved path. So we can only use a symbol which reminds us कि वो जो signed or oriented arc length है, ठीक है? समझ आ गई? So is this clear now? The double derivative with respect to time indicates the acceleration. That acceleration is now equal to minus times g times sin theta. अब इसमें we want to see the simple harmonic motion in it. यहां तक तो हमने कर दिया ना. हमने ये डिस्कशन क्यों स्टार्ट की थी? बिकॉज वी वांट सिंपल हार्मोनिक मोशन. तो सिंपल हार्मोनिक मोशन का टेम्पलेट क्या है अगर हमने यहां ढूंढना है? कैन यू रिकॉल दैट? सिंपल हार्मोनिक मोशन में हम क्या एक्सपेक्ट करते हैं? वी हैव एक्सेलरेशन. And now I am writing down in the language of spring mass. यहाँ पे क्या था? And we knew it was proportional to displacement, and we even had a negative sign, and that negative sign was multiplying. So this is something we expect. So पहले हम ये करें कि if we are going to get that, what do we want to see here instead of ax? We want a s, because x is now replaced by s. Just like x can be positive negative, s can also be positive negative. Yeah, positive negative. What do you want to see there? Minus, and we will have an omega for the simple pendulum. For simple pendulum, वहां पे ओमेगा क्या था? अब ये आपको जहन में रखना है कि ओमेगा की जो वैल्यू हमने वहां देखी थी, जो कि k डिवाइडेड बाय m स्क्वायर रूटेड थी, वो सिर्फ स्प्रिंग मास के लिए थी. समझ आ गई? वो ओमेगा यहाँ पे डिफरेंट होगी, वो सिंपल पेंडुलम के लिए हमें कैलकुलेट करना पड़ेगा. सो एनीथिंग वी, आई मीन दैट विल वर्क आउट, बट व्हाट डू वी नीड इंस्टेड ऑफ एक्स? वी नीड एस. ये मेरे ख्याल में फारिग हो गया है. वी नीड एस देयर. अब क्या क्या अभी तक है और क्या क्या नहीं है? अभी तक हमारे पास क्या क्या आ गया है? ये हमारे पास आ गया है, दिस इज ए एस. माइनस भी आ गया है, वो दोनों नहीं है, ओमेगा स्क्वायर भी नहीं है और एस भी नहीं है. तो क्या करना पड़ेगा? देयर इज ओनली वन वे टू प्रोसीड, अदरवाइज वी हैव टू स्टॉप हियर. You need to somehow change this sin of theta to something which is s. तो पहले आप ये देखिए कि first we need to replace this theta. We know S and theta are related by something. And what is that thing? S equals L theta. तो हमें पता है कि अगर हमने थीटा को यहां पे निकाल दिया साइन थीटा से, तो L बाद में आके उसको S बना देगा, वो टेंशन नहीं है. So it means that we need something which turns sin theta into theta, not to minus theta, because minus theta हम minus sin destroy नहीं करना चाहते. So we need an approximation, and that approximation is we want sin theta to be approximated to theta. When can we do that? When theta is small. और वो आपको पता है साइन का ग्राफ देख ले, साइन का ग्राफ कैसे होता है? आपने साइन का ग्राफ देखा है गौर से? Pay attention to this graph. In which region it behaves like a straight line? क्योंकि remember, आपको याद है ना, आपने ये इक्वेशन देखी थी ना, y equals mx plus c. c को 0 कर दे, y is equal to mx. So when you want y and x to be equal, m has to be 1. So requiring sine theta to be nearly equal to theta is the same as asking the graph of sine to behave like theta. So you want the graph of sine to be just like that, y equals x, passing through the origin with a slope of 1. ठीक है, वो कहां पे हो रहा है? Can you see that? वो कहां पे देख रहे हैं आप? आपको नजर आ रही है स्ट्रेट लाइन? The sine passes through the 0 and it behaves just like a straight line in this region, and that region requires theta to be small. Theta अगर small है तो ये अगर आप कैलकुलेटर देख लेना, and remember theta must be in radians, ये डिग्रीज में नहीं होगा. So if you used your calculators, it turns out that theta has to be between -10 and +10 degrees. तो मैं आपको रेंज बता दूं, try it yourself. Basically theta has to be between 10 degrees. I'm converting it to degrees, right? और डिग्रीज को आप बाद में कन्वर्ट करें रेडियंस में. अच्छा, अब एम आई कंट्रोडिक्टिंग माई सेल्फ? एक तरफ मैं कह रहा हूं कि ये रूल सिर्फ उसके लिए है, रेडियंस के लिए, तो व्हाई एम आई राइटिंग डिग्रीज? बिकॉज आई एम कन्वर्टिंग डिग्रीज टू रेडियन. अगर मैं ये ना लिखता ना फिर ये गलत होता, because I'm converting 10 to degrees. When I convert it, I'll get a small value. 10 is not a small value. Remember, 10 is a very large value. When you convert 10 degrees to radians, you will get a small value, and then you are meeting the condition. ये बात समझ आ रही? So try that with your calculator. Try any value between -10 degrees and +10 degrees, or convert it to radians, and you will see that it will be very close. ठीक है ना? कोई try कर सकता है अभी? Just try, with your calculator. Let's try it with 8, right? So 8 के साथ या डिग्रीज में कर दें, बल्कि डिग्रीज you cannot see it basically. First you divide it by 180 and multiply it by pi, or maybe you can even multiply it by 57, I think. No, divide by 57. But anyway, try this and then calculate this and then take the sign and see if the values match. They must be very close to each other, right? क्या आ रही है? So first I say x equals 8 pi divided by 180, right? तो क्या वैल्यू आ रही है? अब वो मुझे वो वैल्यू नहीं दे रहा मुझे, ये मसला है ना ये. तो बेहतर ये है कि मैं उसको कर दूं. मैं अगर ये लिख दूं यहाँ पे, क्या होता है? 57 होता है पॉइंट, 57.3. अनबिलीवेबल है, उसको वही भी नहीं दे रहा, वो कंप्यूट नहीं कर रहा है, पता नहीं क्या हुआ है इसको. हाँ, तो इसका मतलब है कि वो भी हो सकता था. ठीक है, ये मुझे वैल्यू फिर मिलेगी, सारे ड्रामे कर लेगा, लेकिन वो आई वांट टू सी दैट 0 पॉइंट थिंग, या वो आप कर ले, क्या क्या वैल्यू हाँ। और अब आप उस 10 डिग्रीज का साइन कैलकुलेट करें, दैट शुड बी वेरी क्लोज। समझ आ गई? तो ये हमेशा रेडियंस में दोनों सेम होंगे, ठीक है। आप डिग्री मोड में करें, रेडियन मोड में करें, वो एडजस्टमेंट कर लेंगे, लेकिन द मोमेंट यू क्रॉस 10, सो यू गो टू 11, 12 और -11, देन दिस विल, और ये ग्राफ से भी नजर आ रहे हैं देखो, क्योंकि फिर आप इस रीजन में आ जाएंगे, ठीक है, ठीक है। सो व्हाट वी कैन डू, इफ वी प्रॉमिस दैट आवर this pendulum this pendulum we will not swing it too much, so that we don't allow this theta to go beyond 10 degrees or go beyond -10 degrees, then we can approximate sine theta with theta. And when we do that, we also want our answer in terms of s. We want to see s there, right? We don't want to see theta. So how to convert theta to s? S divided by L. So theta is S divided by L. So how will this equation now change? On this side we will have AS, and on that side, tell me, AS equals minus G. Sin theta has been replaced with theta because we want theta to be small, and that theta will be S divided by L. Can you now tell me what is omega? We got that thing we were looking for. We have AS equals minus G divided by L whole thing times S. So this G divided by L is actually our omega squared. ठीक है, तो omega squared क्या हो गया? And what is omega? No, माइनस नहीं होगा, माइनस तो उसके साथ, माइनस तो इधर भी है, माइनस उधर भी है ना, इसमें माइनस नहीं होगा। तो G is, sorry, omega is G divided by L whole thing square rooted. अब आप इसको कंपेयर करें, स्प्रिंग मास में ओमेगा क्या था? And this equation reminded you something. This equation had two constants, m and k. M was reminding you that you need a rigid body, right? Kinetic energy. K was reminding you that you need a spring elastic energy. Yahan pe, what is L and G reminding you? G reminds you the gravitational potential energy, the capacity of gravitational field to store that energy. तो K का रोल यहां पे G प्ले कर रहा है, ठीक है ना, रॉड नहीं कर रहा, ठीक है। तो नीचे M क्यों नहीं है? नीचे तो M होना चाहिए, जिस तरह वहां पे M है, यहां पे M क्यों नहीं है? M तब होता अगर ये लीनियर स्ट्रेट लाइन मोशन होता। वो स्प्रिंग मास क्या था? ये सर्कुलर मोशन है, और सर्कुलर मोशन में यू नो रोटेशन में न्यूटन लॉ में फोर्स विल बी रिप्लेस्ड विद टॉर्क and mass has to be replaced with moment of inertia. So it turns out that the reason you see L and not M is because this is related to moment of inertia. So this mass, the mass is not important. This mass combined with the L will give you moment of inertia. ठीक है? So we work that out and we have our G over L, और इसी से आप टाइम पीरियड कैलकुलेट कर सकते हैं, ठीक है। And remember the time period or frequency or omega, they don't depend on the mass, they only depend on G and L. So अगर आप ये MCQs को देखें, उसमें वो मास को चेंज कर रहा है, इसको let's solve this question for example. A 3000 ग्राम मास, तो मास की वैल्यू मिल गई हमें, फिर L की वैल्यू मिल गई, आगे oscillate as a pendulum, it has a speed of 0.25 meters per second as it passes through the lowest point. तो ये हम कैसे लिखेंगे बताएं? How do we write this down? you can use label 0 for the start and label 1 when it passes through that point. तो हम क्या कह सकते हैं कि उस पॉइंट 1 पे कौन सी वैल्यू उसने हमें दी है? Speed. We are given the speed. So v1. Why don't we say vx or vs? क्योंकि ये वेलोसिटी नहीं है, ये स्पीड है. So v1 equals 0.25 meter per second. We also know that this has to be the maximum speed. Why? We also know that. Yes. Potential energy. Remember, we know that potential energy and kinetic energy are the only two forms. The total energy cannot change, just like in spring mass, right? So potential energy will be determined by theta or s, right? Because x and theta, s and theta, they behave like x. So the more the value of s, the more the value of theta, the more the value of potential energy. And if it reaches that point where theta is 0 or s is 0, then the potential energy is 0. You can say, oh, the earth is still actually pulling it. So why is the potential energy 0? The earth is pulling it, yes. Yeah, exactly. So the earth is pulling it in this direction and there is no oscillatory motion in this direction. So that will actually cancel. आपको याद है जिस तरह हम वो vertical spring कर रहे थे, तो vertical spring में हमने equilibrium किसको कहा था, जिस पे वो settle हो गया था. So this point, because the particle cannot move up and down, so there cannot be any, even if there is a potential energy, that potential energy will be constant everywhere. So we have to cancel it out. So we are only concerned about this motion. So as far as this motion is concerned, there will be 0 potential energy and all the energy at this point will be kinetic. So this will be V max. Why does it help to write V max? Because we have a formula for V max, and that formula is omega times A. Yeah. So what maximum angle does the pendulum reach? तो उसने क्या मांगा है हमसे? Theta maximum. Theta maximum will only be possible when S is maximum, right? When S is maximum. And S maximum is actually A, right? So what is the value of A here? ओमेगा की जो वैल्यू है वो कहां से आ रही है? हमें थोड़ी देर पहले क्या लिख दिया? G divided by L. And this doesn't require you to use these values. You know G and you know L, right? उसने दिया हुआ है. So omega की वैल्यू आपको वहां से मिल जाएगी. Now use that value in this equation. Remember, omega की वैल्यू आपको वहां से मिल गई ना? और ये किसकी इक्वल है? ये वैल्यू आपको दी गई है, ये ओमेगा आपको वहां से मिल गया, तो यहां से आप ए खुद कंप्यूट करेंगे या नहीं? जब आप ए कंप्यूट करेंगे वो ए किसके इक्वल होगा? एस मैक्स के. एंड वी नो एस मैक्स हैज टू इक्वल एल टाइम्स theta max, and we know the value of L. So you will compute theta max. There is no rocket science. You just follow the rules. इसने यही किया हुआ है. पहले उसने जी ओमेगा कैलकुलेट किया है, फिर उसने ए कैलकुलेट किया है उसी से, एंड उसी से फिर उसने थीटा कैलकुलेट किया. वेरी इजी, ठीक है ना? ये जरा देखिए क्या कह रहा है. A ball on a massless rigid rod oscillates as a simple pendulum. Rigid rod will remind you that the rod cannot have any springiness in it, yeah, and it cannot have any mass either. With a period of 2.0 seconds. So capital T value आपको दी गई है, ठीक है? If the ball is replaced with another ball having twice the mass, the period will be, बताएं. Formula is G over L, और वही G over L ओमेगा, और उसी ओमेगा से अप टी, तो मास को उसमें आ ही नहीं रहा ना. ठीक है, इसका मतलब यह है कि उससे मोमेंट ऑफ इनर्शिया चेंज नहीं होगा ना, मास चेंज हो रहा है सिर्फ. ये बाकी आप खुद कर ले. ठीक है. सो अभी ये इसने ये स्लाइड इसलिए बताया है कि नाउ यू हैव अ टेम्पलेट, whether you are dealing with spring mass or a simple pendulum or anything else. I can even give you another example of oscillations, which is your internal clock. You have an internal clock, and that internal clock helps you experience time even when you don't have a watch. Yeah. So there are actually protein levels, and the concentration of those, there are chemical reactions, and the concentrations actually change. There is an equilibrium level of concentration, and it goes high and then it goes low, and that helps you experience time. जेट लैग इसी वजह से होता है. अगर आपका इंटरनल क्लॉक ना होता, there would be no such thing as jet lag. ठीक है ना. तो that is another type of oscillation. ऑसिलेशन मैं सिर्फ ये बता रहा हूँ कि ऑसिलेशन में किसी चीज का मूव करना जरूरी नहीं है. या ये जो इन्फ्लेशन आती है, प्राइसेस गो अप डाउन, तो मनी इज नॉट समथिंग व्हिच मूव्स लाइक दैट. या आई मीन थिंग्स गेट वर्स. तो ऑसिलेशन जो ये मैं क्यों बता रहा हूँ, क्योंकि जो इक्वेशन है सिंपल हार्मोनिक मोशन का, उसमें यू कैन हैव एनी वेरिएबल, बी इट प्राइस, बी इट position, be it angle, be it anything. It can be anything. You will call it simple harmonic motion only when the equation represents a sinusoidal wave. आपको सिर्फ साइन वेव चाहिए, वो वेदर का हो, वो ठीक है ना, वो वेदर का डेटा हो, या वो मोशन का हो, या वो concentrations का हो, you will still call it simple harmonic motion. Even the electrical circuits, they can have, तो जो AC हमें मिल रहा है, अगर ये फॉर एग्जांपल वो ना होता, so I mean you can imagine this to be a simple harmonic motion. Okay, so now we how do we deal with physical pendulums? क्योंकि physical pendulum में you will have a rod and which will have mass, और वो इतना mass होगा और उसके साथ कुछ चीज अटैच भी नहीं होगी. तो how do you apply the theory of simple pendulum on a physical rod? अब देखो ना, इसमें पूरा mass इस distributed है और वो अलग से mass कोई नहीं है, तो आप क्या करेंगे? If you want to model this as a single particle, so where will you put all the mass? At the center of mass, not here, not there, at the center of mass. तो अब आप इसको रिप्लेस करें, ये आपका फिजिकल वर्ड है, रियल वर्ड. अब आप इसको ट्रांसलेट करें मैथमेटिकल वर्ड में. तो मैथमेटिकल वर्ड में आपके पास क्या है? You have a massless rod and all the mass is there. तो जो इसका मास है कैपिटल M, वो सारा आप कहां पे लगाएंगे? और ये रॉड क्या होगा? मासलेस होगा. अब आपसे मेरा क्वेश्चन ये है कि इसका लेंथ कितना होगा? व्हाट विल बी द लेंथ? इसका लेंथ कितना है? इसका तो ये लेंथ यहां से यहां तक है ना, ठीक है. इसका लेंथ कितना होगा? ये आपका यहां पे आपने इस रॉड को कहीं से फिक्स भी करना है, तो अगर आपने इसको यहां से पिवट किया है तो फिर ये मैटर नहीं करेगा. तो इस पॉइंट से सेंटर ऑफ मास तक जो लेंथ है, वही लेंथ आप इधर यूज करेंगे, ये लेंथ यूज नहीं करेंगे. समझाएंगे? क्योंकि इफ दिस होल थिंग इज टू बिहेव लाइक अ पार्टिकल, ओनली दिस लेंथ मैटर्स. ठीक है, तो आप उसको वहां पे कर लेंगे. फिर आप इसका मोमेंट ऑफ इनर्शिया कैलकुलेट करेंगे, उसके लिए कोई टेबल्स है, क्योंकि अनफॉर्चुनेटली इस फिजिक्स के कोर्स में वी कैन नॉट गो टू मोमेंट ऑफ इनर्शिया. That needs multivariable calculus, and you have not actually studied that course yet. So we'll just use tables. If there is a question, I will provide you a table of moments of. तो उस टेबल में क्या होगा? मास होगा, लेंथ होगा और शेप होगा. सिलेंडर का अपना होगा, ठीक है ना, स्फीयर का अपना होगा. अगर उस तरह का कोई क्वेश्चन आपको मिलता है, you can solve this question. But anyway, leaving all that detail aside, what you can do as you will still be able to write an equation like that. जिस तरह हमने यहाँ पे इक्वेशन लिखा था ना सिंपल पेंडुलम के लिए, तो इसके लिए यहाँ पे क्या है? कैन यू रिकॉग्नाइज द सिंबल? टॉर्क. वहां पे हमने फोर्स लिखा था, वो हमने जो इक्वेशन लिखी थी, we still used force because this was easy to handle, right? More appropriate even there would have been to replace this with torque. So when I replace this with torque, how does that equation change? I'm not writing it down, but I want you to think about it. It must multiply what? L, क्योंकि L उसका है ना, वो moment arm इसका L है. So bring that L there. ठीक है? So then it will simply be torque, and then you will have all these equations. So you can even write this equation there as well. So when you do that, तो जिस तरह F equals ma है, तो when you replace F with torque, m has to be replaced with moment of inertia, and a, the linear acceleration, has to be replaced with angular acceleration alpha, right? So the linear acceleration a will be replaced with alpha, the angular acceleration. Mass will be replaced with moment of inertia, and you typically see I, capital I, and force is replaced with torque. समझ आ गई बात? तो आप देख लें कि यहां पे टॉर्क हो गया, और वो जो आर्क लेंथ है वो क्या हो जाएगा? L टाइम्स थीटा, राइट? तो ये आपका S हो जाएगा, और ये आपका M टाइम्स G है. ठीक है? तो नहीं, अभी है, अभी हमारे पास टाइम है. So if you actually follow the same path just as we did for simple pendulum, जिस तरह वहां पे हमें ओमेगा की वैल्यू मिल गई थी स्मॉल g डिवाइडेड बाय कैपिटल L स्क्वायर रूटेड, तो यहाँ पे भी we can get something like that, and this is not part of the course. तो आपने सिर्फ ये नोट करना है कि वो वहां पे जिस तरह g नोमिनेटर में था, इसमें भी g नोमिनेटर में है. ठीक है? वहां पे डिनोमिनेटर में L था, यहाँ पे I है, मोमेंट ऑफ इनर्शिया, बिकॉज इट्स अ डिफरेंट प्रॉब्लम. सो m टाइम्स L डिवाइडेड बाय I. ठीक है? और इसको मैं स्किप कर रहा हूं इन टॉपिक्स को, ये जो इसके क्वेश्चंस है इसको मैं स्किप कर रहा हूं. ओके, सो देयर आर एक्चुअली टू मोर टॉपिक्स एंड आई विल जस्ट pass through them in a way that does not require any calculation. Okay, so far, whether it's spring mass, whether it's simple pendulum, the total energy doesn't change. So you only have those two types of energies. But if you have some other phenomena like drag or friction, right? So then you cannot have simple harmonic motion in a spring mass or in simple pendulum. Why? Because some of the energy will be converted to thermal energy, like by friction or by drag, and then the total energy will not be constant. The total energy will be decreasing, right? So it means that if you write the equations, you will have a spring force, but you will also have, this is a spring force, but you will also have a drag force. And drag force, anything that happens because of drag force cannot be stored in kinetic energy or potential energy. It has to actually get converted to thermal energy. तो इसका जो इक्वेशन है वो सिर्फ मैं फाइनल बता रहा हूं. ये अगर सिंपल हमारे मोशन होता तो हमारे पास उसी टाइप पोजीशन, एम्पलीट्यूड, कोसाइन ओमेगा टी प्लस फाइ नॉट. बट नाउ वी हैव समथिंग मल्टीप्लाइंग दैट कोसाइन, एंड दैट थिंग इज एक्सपोनेंशियल. और एक्सपोनेंशियल में जब भी माइनस साइन आता है, इसका मतलब है कि वो इट विल डिक्रीज इन एम्पलीट्यूड. ठीक है? So the graph will look like this. Instead of having oscillation of the same amplitude, that amplitude is now changing, and you can even have a formula for the amplitude. Instead of calling it A, we will now call it X max, and that X max changes with time. So it still has A in it, but that A gets smaller and smaller with time, right? और इस टाइम के साथ जो चीज मल्टीप्लाई कर रही है b, दैट इज एक्चुअली अ कोएफिशिएंट. ये देखिए, ये आपने सिर्फ ये नोट करना है कि जो ड्रैग फोर्स है, वी समहाउ assume that there are many assumptions that the drag force, we will always have a negative sign because it's a resistive force. It depends on speed, right? The force depends on velocity, the magnitude depends on the speed, and this b is the coefficient of drag, right? So this b appears there in the equation. ये आप चेक कर लें, वो टाइम के साथ क्या मल्टीप्लाई कर रहा है b. So the more the damping constant, the more this effect. और m उसको काउंटर कर रहा है. रिमेंबर m इज द डिनोमिनेटर. तो इसका मतलब है कि m अपना रोल प्ले कर रहा है. m स्टोर्स काइनेटिक एनर्जी. So larger m would mean larger kinetic energy. So m will actually reduce the effect of this factor, but b will increase it. So b divided by m determines how much this effect is serious. Yeah. ये आप इवन ये प्लॉट भी कर सकते हैं. अगर एम्पलीट्यूड, इफ द एम्पलीट्यूड डजंट चेंज विद टाइम, यू हैव सिंपल हार्मोनिक मोशन. Energy conserved. For different values of b, yeah, the drag coefficient, you can have different. These are called envelopes. This is just a name. ठीक है. और चूंकि इसमें e आ रहा है तो इसको लोग क्या कहते हैं? Exponential decay भी कहते हैं. You can even write this equation in general in this form. Instead of writing b and m, you can write it as something divided by a value, and that value is then called the decay constant. So you can have a decay constant for spring mass. You can have a decay constant for simple pendulum. Whenever, so जब भी simple pendulum में friction वगैरह आ जाएगा या drag, तो उसका एक decay constant होगा. Similarly, spring mass में आ जाएगा. You can even have these things in electrical circuit. किसी ने electrical circuits में time constant नाम सुना हुआ है? Time constant. ये decay constant उधर time constant कहलाता है. ठीक है. ठीक है. और ये रेजोनेंस तो आपने मेरे हाल में पहले भी पढ़ा हुआ है. सो रेजोनेंस का टॉपिक मैं सिर्फ एक बात बताता हूं कि वो आता क्यों है. अभी तक हम जो कह रहे थे या सिंपल हार्मोनिक मोशन था या डैम्प्ड था, yeah, when there was friction, but we never talked about external force. Yeah. So what if you have external force, like you have there some outside force driving the oscillation and not letting it damp. ठीक है ना. जिस तरह आप फुटबॉल खेलते हैं ना, so you never let the ball stop. So it's called forced oscillations or driven oscillations. तो वहां पे ये क्वेश्चन आता है कि एक उसकी नेचुरल फ्रीक्वेंसी होगी ओमेगा जब कोई फोर्स नहीं होगा एक्सटर्नल, और जब आप फोर्स अप्लाई करेंगे तो वो फोर्स भी ऑसिलेटिंग, बिकॉज द फोर्स हैज टू बी ऑसिलेटरी ट्रू. यू कैन नॉट ड्राइव समथिंग बाय अ force which is not oscillating. So the frequency of the driving force is one quantity, and the frequency of the system without the external force, उसको हम कहते हैं natural frequency जो ओमेगा है. If those two frequencies match, then the amplitude gets really large और उसका हम resonance कहते हैं. That's the only thing you need to understand. ठीक है.